Lesson 4.3, 5-number summary. Our objective for this lesson is to be able to give the 5-number summary and draw a box plot for a data set. In this lesson and the next lesson, we're going to be talking about ways to measure the variation in a distribution. And the first way is going to be with the range. The range is simply the difference between the highest and lowest values in a data set. So we find the highest or maximum value in the data set and subtract from that the lowest or minimum value in the data set. And that difference we call the range. Next, we need to define quartiles. So quartiles are values that divide the data distribution into quarters. The lower quartile will divide the lower fourth of the distribution from the rest of the distribution. And the upper quartile will divide the upper fourth of the distribution from the rest of the distribution. And then the median is the middle quartile. So the way to find these quartiles is to first find the median and then find the median of the lower half. And then to find that, and that will be the lower quartile. Then you find the median of the upper half, and that's the upper quartile. All right, so the 5-number summary is a description of a distribution consisting of the lowest value, the lower quartile, the median, the upper quartile, and the highest value. So the lowest value and the highest value will be obvious. And we've already talked about how to find the median. The median will just be the middle number in the distribution, or if there's an even number of data points in the data set, then we're going to take the middle two numbers, and halfway between those will be the median. Then to find the lower quartile, we take the lower half of the data set, and if there's an odd number, we'll just ignore the median and take everything below the median. And then we find the median of that half, and that's the lower quartile. And then we do the same with the upper half, and that will be the upper quartile. And those 5 numbers together make our 5-number summary. All right, so to represent the 5-number summary visually, we're going to draw a box plot, or it's sometimes called a box-and-whiskers plot. And the steps for drawing a box plot are first to draw a number line that spans all the values in the data set. So we just need to look at the minimum and maximum values of the data set and make sure that our number line is big enough to cover all of that entire range. Step 2 is to enclose the values from the lower to the upper quartile in a box. So we'll put a line where the lower quartile will be, and then we'll put a line representing the upper quartile, and then we'll connect those lines together in a box. The thickness of the box doesn't matter. It's just the length of the box between the lower quartile and the upper quartile. Step 3 then is to draw a vertical line through the box at the median. So what we'll have at this point is just a box with a line at somewhere in the middle of that box. And those 3 lines then, the left side of the box will represent the lower quartile, the line in the middle will represent the median, and the right side of the box will represent the upper quartile. And then step 4 is to add whiskers, or just straight lines, extending from the box to the lowest and highest values. So the ends of those whiskers will represent the range, the lowest and highest values, and then the box in the middle will represent the middle half of the data set from the lower quartile to the upper quartile. Our example gives us 2 different data sets, and I've written them on the board here, one in black and one in red. And we're told that these data sets represent 100-meter dash times, and there's 20 in each set. And we're asked to compare the two data sets using a 5-number summary and a box plot. So let's start by giving a 5-number summary for each of the data sets. So first, for the black data set, we're going to write the lowest value, the lower quartile, the median, the upper quartile, and the highest value. And that's going to be our 5-number summary. So the lowest value is just going to be, notice that these are in order, by the way. They go from lowest through the first row and then down to the second row up to the highest. So the lowest value is just going to be this value here, 9.92. And the highest value is going to be right out here at 10.38. All right, now to find the median, since these are all in order, the median is going to be relatively easy. We just need to find the value that's halfway between this value, the 10th value, and this 11th value. So halfway between 10.13 and 10.14 is going to be 10.135. Now to find the lower quartile, we're going to find the median of the first half of these values. So that's going to be halfway between this value, the 5th value, and this value, the 6th value. So 10.06 and 10.07, halfway between those is going to be 10.065. And then for the upper quartile, we're looking for the median of this second row here, the upper the upper half of our data set. So halfway between 10.18 and 10.1 or 10.21 is going to be 10.195. All right, so that's the 5-number summary for that black data set. For the red data set, our lowest value is going to be here, 9.89. Our highest value is out here, 12 flat. Our median is going to be halfway between this value, 10.98, and 11.05. So that's going to be 11.015. And then our lower quartile is going to be the median of the top row, which will be halfway between 10.35 and 10.41, which is 10.38. And then the upper quartile will be the median of the second row, which will be halfway between 11.55 and 11.76, which would be 11.655. All right, so now let's draw a box plot. So first step is going to be to draw a number line. So we'll make our number line with values that are sufficient to cover the entire range. So our lowest value in any of these data sets is 9.89, and our highest value is 12. So we want to go, maybe we'll start here at 9.5, and we'll go 10.0, then 10.5, then 11.0, then 11.5, and 12.0. So there's our number line. And then above this number line, we're going to draw our box plots. So let's start by drawing the red one. So we're going to start by drawing a box with the left half of the box is going to be at the lower quartile. The right half of the box will be at the upper quartile. So we start at 10.38, and we'll draw a line right about there for 10.38. And then 11.655 is going to be about here. And we'll connect those two lines and make a box like that. Then we're going to draw a line in this box where the median will be. So the median is going to be right about at 11. So right about there will be our median. And then we're going to draw whiskers, so the little, just a line out from the edge of the box to the lowest value, which is at 9.89, so about here. And then another whisker out to the highest value, which is at 12. So that'll bring us out to there. So here's our box plot for this red data set. Now let's draw the box plot for the black data set. Here, our lower quartile is 10.065. So that's going to be 10.065 is right about there. And then 10.195 is the upper quartile. So this is going to be a much smaller box here. And then our median is at 10.135. So maybe right about there for our median. And then we'll draw the whiskers out to 9.92, which is just going to be that little bit of a whisker right there. And then out to the highest value at 10.38. And so that's going to be let's see, I think this lower quartile, oh no. That's right. This should go out to 10.38, which is where this lower quartile was there. Let me make sure that the upper quartile is one. That's right. So you can see that this is a much smaller box plot than this one, meaning that the variation in this black data set is much smaller than the variation in this red data set. You can also see that the center of the data set, represented by the median, is quite a bit lower in the black box. So we have a lower center and a lower variation in the black set, which would tell me that maybe the red set represents times from some regional qualifier where the black set would be the championship, the Olympic Games. These are very fast times for a 100-meter dash. And so once you get to the highest level, you're going to see a lower variation as well as lower times.